Yes, today our next topic is the Stackelberg model. So in the last class we have discussed about the very first oligopoly model, that was the Cournot model. Do you have any problem from Cournot model? Is there any problem from the Cournot model which we have discussed in our last class? Is there any problem? Okay. In that case, I'm going to start the next model, that is the Stackelberg model. Now, Stackelberg model, look at the first bullet. The first bullet is showing the Stackelberg model is the quantity leadership model. Okay, the Cournot model was not the leadership model. Any type of leadership was not there. Right? They are independent. They are taking their decision by their own. That one's decision is not dependent on another's decision in terms of price and quantity and all. So that was the Cournot. But here, just another extreme where the quantity based on the quantity decision of one firm, another firm will take its decision. Okay, so it is the quantity leadership model. That means, see here, as you know, we are discussing oligopoly structure with two firms. So it is also the duopoly structure, and among these two firms, one firm is a leader and another firm is a follower. Okay, so that is how it is the leadership in terms of what? Leadership means in terms of quantity. That means the leader will choose quantity first, because you know the market size is fixed. Market size is fixed and two firms are catering this market. Fine. So one of them is leader, so that firm will decide its output first, and based on his output decision, follower will choose his quantity. Is that okay? Is it okay? Do you have any problem?
No, ma'am.
Okay, fine. So this is the Stackelberg quantity leadership model. So first firm, that is the leader firm, will choose the quantity decision first, and based on his decision, the follower will choose his quantity. So you can understand where is the difference between the Stackelberg and Cournot. When we are discussing about the Cournot, we said that they are independent in that sense, right? When the farm one is taking decision, he is indifferent about the quantity sold of the farm two, and the same thing for farm two. But here it is not. Okay, one farm's decision is dependent on the quantity decision of another farm from very beginning. So that is the leadership model. So the second bullet is showing two firms. As I already said, we will discuss everything in terms of two firms because of the duopoly structure. Okay, so we will follow the duopoly structure. Now one firm is a leader and another firm is a follower. And say firm one, you can choose any of them. But just for the simplicity, say firm one is the leader firm and firm two is the follower firm. Okay, so this is just the decision. You can take just opposite, that farm 2 is the leader, farm 1 is a follower. Nothing will happen. Okay, everything will be very same. But don't worry about that. Say farm 1 is a leader. Now tell me if you can understand this structure. This is the basic structure. We will discuss it in details. But if you can understand it, so just tell me, uh, you know the concept of conjectural variation, right? I'm showing you again. The concept of conjectural variation, yes. The conjectural variation CV of ith form is del Qj by del Qi. Sorry. Del Qi by del Qj. Okay. So conjectural variation of the ith form is del Qi by del Qj. Fine. So I think it is clear to you that what is conjectural variation. So if conjectural variation is clear to you and you know what is a Stackelberg model, so tell me what will be the conjectural variation of farm 1, that is the leader farm. Just make a try. What will be the conjectural variation of the leader farm? I'm asking that whether conjectural variation will be zero or non-zero. That is my question. Conjectural variation of the leader form is zero or non-zero. What will be the correct one? What do you think? The first decision is taken by the leader. Based on the decision of the leader, the second form will choose his output. That is the way. Hmm. Now, given this structure, you know conjectural variation. So, what will be the conjectural variation of leader and what will be the conjectural variation of the follower? Whether they're all zero or non-zero or what? Only two options, either zero or non-zero. So, which one?
Ma'am, it should be non-zero.
Yes. Who's non-zero? Leader. You are talking about the leader. The leader's conjectural variation is non-zero. That is what you are saying.
Yes, ma'am.
And what about the follower? Will it be non-zero also?
Ma'am, I'm not sure, but leader should for leader it should be zero and follower it should be non-zero.
Yes. Anything else you want to say? Anyone? Anyone else other than Keshav? Anyone else? I think it is Ishan, na?
Yes, ma'am,
Yes.
Ishan.
Yes, yes, yes. Other than Ishan, anyone else in the class who want to say, who want to say something different? Ishan is saying for leader conjectural variation is zero. For the follower, conjectural variation is not zero. So is it okay for all? What do you think? If you think something different, just feel free and tell us. Yes. Okay. No answer is coming, so I'm not wasting the time. So Ishan, unfortunately, your answer is wrong. Why? Apparently what you are thinking given the structure, apparently it's okay, but actually it's wrong. It will be just opposite. Why? Look, what is the conjectural variation? Conjectural variation of the leader is the change of followers quantity with respect to change of leaders quantity, right? Yeah.
Yes, ma'am.
The change of followers quantity with respect to change of the leaders quantity. And for the follower, just opposite. It is the change of leaders quantity. Okay, first start from the followers point of view. Huh? So for the follower, the conjectural variation is the change of leaders quantity with respect to change of the follower. Right? Change
Ma'am,
of
but it is
leaders.
written del qi by del qj. So I is in the numerator for
Yes, yes,
ith
yes,
form.
yes. I'm sorry. I'm wrong. I'm wrong. Yes. So conjectural variation of the ith form. This is the change. Okay. So for the follower, it is the change of the quantity of the follower due to change in the quantity of the leader. Right?
Yes, ma'am.
Okay. Now I'm right, I think. So here come. Follower knows that whatever he will do with his quantity, leader will not concerned about it. Okay, it is not the concern of the leader that what follower is doing, because I am the follower. Say I am the follower and you are the leader. Okay, so leader is not interested about the follower's decision. But is that okay? Is that okay?
Yes, ma'am, I'm getting it.
Hmm? So follower knows that whatever I will do with my quantity, leader will not change his decision. But leader knows that there is a follower, right? So leader knows there is a follower. So if I will change my decision, follower will change his decision. Hmm? So for the leader, the conjectural variation is non-zero because he knows if I will change my quantity, follower will change his quantity. But follower knows if I will change my quantity, leader will not change his quantity. So for the follower, conjectural variation is zero. For the leader, conjectural variation is non-zero. For the follower, conjectural variation is zero. Is it okay? Do you get the
Ma'am,
explanation?
can you repeat the meaning of conjectural value? Variation, sorry. Conjectural variation.
Yes. Conjectural variation of the ith form is the change of the quantity of the ith form due to, sorry, the change of the quantity of the jth form due to change in quantity of the ith form.
So it is Qj by Qi.
Yeah, Qj by Qi. Yes, yes, yes,
For ith form, it is J by I.
yes. So follower knows that if I will change my quantity, then leader will not change his quantity. So del Q leader by del Q follower is zero for the follower. Is that okay? But for the leader, leader knows there is a follower. So if leader will change his quantity, then follower will change his quantity as well. So del Q follower divided by del Q leader should not be divided anyway. With respect to del Q leader is non-zero for the leader. Okay.
Ma'am, but numerator has, if numerator has leader, then it should be for leader as well. And if numerator has follower, then it should be for follower.
Why bolo? Tell me again.
If we are considering del q leader by del q follower, then
Hmm.
it is for leader, right?
Del Q leader by del Q follower, then this is for leader. Yes. Yes. Del Q leader by del Q follower. This is for leader.
So ma'am, there should be
Yes.
no
Okay.
effect
Okay.
on.
Just stop here. I'm explaining that part only. Huh? So del Q leader by del Q follower. This is for leader. So leader knows that I have a follower, but if follower will change his quantity, as I am the leader, I will not change my quantity. So del Q leader portion is
Zero.
দাঁড়াও দাঁড়াও কি সব বলে ফেলছি just a minute, just a minute, let me go back there. Yes, del q leader by del q follower. So if is it wrong, give me 1 minute, huh? Just give me 1 minute. Yes, this is wrong. That is the problem. That is the problem. I'm very sorry, huh? From the very beginning, it is wrong. Just a minute. Give me 1 minute. Yes. Now is it okay? Look.
Yes, ma'am. Now it's fine.
That is wrong. That is wrong. I'm very sorry. হ্যাঁ আমি একটা বাজে mistake করেছিলাম. Del Qj by del Qi. This is the CV, the conjectural variation of the ith form. Okay. So here, conjectural variation of the leader. Okay. Conjectural variation of the leader is del Q follower by del Q leader, and leader knows there is a follower. So if I will change my quantity, follower will change his quantity because he is my follower. So for the leader, conjectural variation is non-zero. Okay. And if it is leader, then if I is the leader, sorry, if I is the follower, then it will be del Q leader by del Q follower. And follower knows I am the follower, so leader will not change his decision based on my decision because I am follower, he is leader. So in that case, del Qj will be 0 for the follower. Del Q leader will be 0 for the follower. So for the follower, conjectural variation is 0. Now is it clear? I'm very sorry that is a mistake that creates the confusion. But now I think it is okay. Del Qj by del Qi is the conjectural variation of the ith form. Okay.
Yes, ma'am. It's clear.
So here is the Stakeholder model. Okay. So what is a Stakeholder model? I am telling you again that it is a duopoly structure. One farm is a leader, another farm is a follower with respect to the quantity. Farm 1 is the leader. So conjectural variation of farm 1 is non-zero. And farm 2 is a follower. So conjectural variation of farm 2 is 0. Okay. So this is the thing. This is written over here. Conjectural variation of farm 1, that is the leader, is non-zero. And conjectural variation of farm 2, that is the follower, is 0. Fine. Now my handwriting is coming. Just a minute. Yes. So here we are going to discuss a new topic. Okay, new concept actually. That is the isoprofit curve. For each year, I am referring only for this part, only for this isoprofit curve. The reference is Ryan and Pierce, and every year I am referring this part, this book for this part. But I don't know whether you will get this part. If you have this part, somehow, if you have this book, Ryan and Pierce, with you, because it is in the library. I don't have my own copy. Okay, it is in the college library. So by chance, any of you, if you have Ryan and Pierce, just read this portion, that is the isoprofit curve from Ryan and Pierce. Okay, it's beautifully explained there. That isoprofit curve, only that isoprofit curve from Ryan and Pierce. This is my reference. But unfortunately, I cannot give you that part in the LMS as I don't have the book. Anyway, I'm trying to explain it mathematically first. So isoprofit curve, what is that? Iso, you can understand, iso means same, and profit you know. So the curve along which the profit is constant, the curve along which the profit is same. Okay, so this is called isoprofit curve, just like indifference curve, just like isoquant. Hmm. But the shape is not like the earlier curves. Anyway, so what is the definition? Say we are going to draw, there are two forms. No? There are two forms, form 1 and form 2. We are trying to find out the shape, the slope, and everything about the form 1's isoprofit curve. Okay. So as the definition is showing, the profit of form 1 is pi 1 bar because it is isoprofit. Okay. So it's pi 1 bar. Now pi 1, that is the profit of firm 1, it is dependent on Q1 and Q2 because it is the quantity dependent model. So Q1 and Q2 both are influencing the profit of the firm 1. The firm 1 may be leader, may be follower, I don't know. Anyone, it's a firm 1. Okay. So the and that is equal to pi 1 bar. So if you differentiate d pi 1 is equal to 0. So the right hand side will be del pi 1 del q1 dq1 plus del pi 1 del q2 dq2 is equal to 0. So what is your dq2 dq1 is like this. Okay, if you are just taking, it's just like the finding out the slope of any of the curves. Okay. Yeah. So this is the slope of your isopropyl curve, but that is not giving you any idea that what will be the shape. But somehow you find out the slope dq2 dq1 because here the dependent variables are q1 and q2, so you have to draw the curve in the axis q1 q2. Okay, so dq2 dq1 is this. Now you have to find out the value, otherwise you cannot draw. So for that again we are taking pi 1. Okay, so pi 1 is p function of q, q is q1. So pi 1 is a function p function of q into q1. Q is what? Q is equal to q1 plus q2. The total output of the oligopoly market. Okay, and q1 into q1, there is pq1 minus c1 bar. For simplicity, we are assuming marginal cost as constant. You can assume cost as a function of q1 and all, but just for simplicity, just to avoid the complication from the cost side, we are making it a constant. That's all. Okay, so c1 bar. Now what is d pi 1 dq2? Del pi 1 del q2, because pi 1 is a function of both. So when you are going to differentiate with respect to one variable, it should be del, right? So del pi 1 del q2, it will be p prime. Now within bracket, you have q1 plus q2, right? So just a minute, let me put her. Yes. So your q is q1, that is the total output of the oligopoly industry, q1 plus q2, right? So what you are doing, you are differentiating p is a function of q, right? P is a function of q, so let me write it. P is a function of q, so p is a function of q1 and q2. So if you differentiate p with respect to q2, first of all you will get p prime. Fine. First of all, you will get p prime. Now within bracket, you have del q1 del q2. Okay. Within bracket, you have one del q1 del q2, it will be 0. Plus del q2 del q2, it will be 1. Okay. So del q1 del q2 will be 0, del q2 del q2 will be 1. So that will be 0 plus 1 and the bracket closed into q1. Okay, into q1 because that q1 is there. And again, when you are going to differentiate the next part, that is the p function of q into del q1 del q2, it will be again 0, and that c1 bar, so the differentiation will be 0. So finally what you have, p prime q1, that part you have. Now q1 is the total quantity produced by the farm 1. It is definitely positive, and p prime is nothing but the slope of your demand curve. So p prime is negative if there is law of demand. So p prime into q1 is less than 0. So what is that actually? Del pi 1 del q2, it is your denominator. Look, It is your denominator. The slope of the isotropic curve, it is the denominator. So you know, somehow you find out that okay, the denominator is less than 0. But what about the numerator? The numerator, look, before going to the numerator portion, we have to know what is the elasticity. Elasticity, the mod value, as it is the mod value, that is why I am writing that negative sign, del Q del P into P by Q. So I can write it P by Q, and you know, del P del Q is P prime, right? Del P del Q is P prime, so it will be 1 by P prime. So P by Q into 1 by P prime is like this. So 1 by mod elasticity is just the inverse, so negative of P prime Q by P. That we need actually. Now I am coming back to my profit equation, that is pi 1. Okay, so pi 1 is a function again. Here I am writing, look, here I am writing P function of Q1 plus Q2 into Q1 minus C1 bar. Now I am differentiating that profit equation with respect to Q1. What I did initially with respect to Q2, now I am going for Q1 because this is required as a numerator is this one, del pi 1 del Q1. So I have to find out the value. So here it is del pi 1 del Q1. Now again I am doing the same thing, P prime within bracket 1 plus del Q2 del Q1 plus Q1 plus P. Okay. P is why? Because P into del Q1 del Q1. So that part is 1 and that C1 prime is missing now. So del Q2 del Q1 just like before it is equal to 0. Here we have written is that del Q1 del Q2 0. Here del Q2 del Q1 will be 0. So I left P prime Q1 plus P. Okay. So I'm taking P as a common because I cannot find out the value because P prime is negative. Q1 is positive. P is the price, positive. So what will be the summation? We don't know. So you have to go further. So I'm taking P common, 1 plus P prime into P by Q1. Okay. So okay. So here, just like you know, the P is taken, so Q1 into Q prime is multiplied. So Q is actually 1 by Q is multiplied. So here the Q again, so that Q will cancel out. So you are getting 1 minus Q1 by Q mod elasticity. Okay. So here, what is Q1 by Q? Actually, Q1 by Q is S1. Because Q1 is the total quantity produced by farm 1 and Q is the total market output. So we can say Q1 by Q is the market share of farm 1. Market share of farm 1. Okay. So that is why it is written as S1, share. So S1. Okay. So what is your del Q, what is your del Q1, del P1? It is P into 1 minus S1 by mod of P1. Okay. So again, we are again confused because we don't know what will be the sign. But we know actually. Why? Look, if del Q, because this is what? This is del Q1, del pi 1 del Q1, right? This is del pi 1 del Q1. So you have del pi 1 del Q1 is equal to this. So it will be greater than equal to less than 0 if your right hand side will be greater than equal to less than 0. And if it is, then 1 is greater than equal to less than S1 by E1. Or if you take that E1 here, then mod E1 is greater than equal to less than S1. Now what is S1? S1 is the market share of farm 1. So what are the two extreme points? If the market share is 0, that may be because he is not sharing a single unit of the market, then it is 0. Or he is scattering the total market, so it will be 1. So market share, the range of the market share, that is S1, it will be less than equal to 0 and less than equal to 1 and greater than equal to 0. So 0 to 1, this is the range of the market share. So it is what? It is actually a positive fraction. S1 is a positive fraction. Right? Now what about the elasticity? you know the elasticity. At this portion that is just above the middle portion, if you are assuming the demand curve is a straight line demand curve, then just above the midpoint, the elasticity is greater than 1. At the midpoint, it is equal to 1. And after that, it is less than 1. All of you know that. Right? So you know the range of elasticity, you know the S1. Now look, if your demand is here, if your demand is in this portion, that means elasticity is greater than 1. Elasticity is greater than 1. That means elastic. In that portion, elasticity, that is E1, is greater than S1 because S1 cannot be greater than 1. It is always less than 1. So E1 for this part, E1 is greater than S1 at this part. That is when E1 is equal to 1. At this part, E1 is equal to S1. And after this part, E1 is less than S1. So this is how you can find out the range where these values will change. And as these values are changing, your del pi 1, del q1 will also change. So for this part, I can say for this part, that is the demand curve above the midpoint, del pi 1, del q1 is greater than 0. And for the lower portion, del pi 1, del q1 will be less than 0. Okay, and if del pi 1 del q1 is greater than 0, look at this slope. Del pi 1 del q1 is greater than 0. Del pi 1 del q2 is always less than 0. So denominator is less than 0 with a negative sign. So the ratio other than del pi 1 del q1, this value is positive. But for the demand curve, above the midpoint, your del pi 1 del q1 is also greater than 0. That is a positive. Okay. If it is positive, then this is positive. Your numerator positive, denominator negative with a negative sign. So del pi 2 del q1 will be, that is the slope of the isoprofit curve will be greater than 0. That is positively sloped. So the isoprofit curve is positively sloped. When the demand curve is elastic, when it is at the midpoint, that is unit elastic, then your del pi 1 del q1 will be equal to 0. So 0 by something is 0. So the isoprofit curve slopes is 0. And after that, del pi 1 del q1 will be less than 0. So it is less than 0. Numerator less than 0, denominator less than 0, ratio is greater than 0 with a negative sign. So the isoprofit curve will be negatively sloped. So what will be the shape of the isoprofit curve? Look here. This is the demand curve. Okay, this is the demand curve. Above the portion, that means here, isoprofit curve is positively sloped. Just at this point, it is 0, and then after it is negatively sloped. Okay, and it is we are measuring Q1 here and Q2 here. That is why the slope is dq to dq1. Nah? So is that okay? Just the explanation, but I don't think that everything will be okay for all. But somehow if you have some conceptual question that this question is not clear, because this is just the mathematics, nothing else. When I will share this part in your LMS, you can check that slides and you can understand. But if you have any conceptual problem that this portion is y, that portion is y, so you can ask me now. So this is your isoprofit curve, huh? That green ones, these are the isoprofit curves. This is the isoprofit map actually. 3 curves are there. But up to this point, if you have any question to ask me, then I will. Otherwise, I will explain the properties of the isoprofit curve. Isoprofit curve is of these 3 slides. Here, here, and here. From anywhere, if you have any query, ask. For this part, the reference is Ryan and Pierce. I'm repeating again. So no one is asking any question. I don't know whether I'm audible or not, whether my network is
Ma'am, you're
what
audible.
not. Okay, okay, fine, at least audible. So my network is working. Um,
Ma'am, can you spell out that author's name?
oh, Ryan and Pierce, Ryan, Ryan and and Pierce, Pearce.
Okay, ma'am.
It's very, very small, very thin book. But this part is beautifully explained there. The second-hand books are also there. I should collect one, but anyway, I don't have right now. Hmm. So this is isoprofit curve. Now, what are the properties? First property is very much visible to all of us. That is, it is inverted U-shaped. Okay, it is inverted U-shaped. The second property is also very much clear that they are parallel to each other because it's a curve. The third property, actually there are four properties. Third and fourth, these two properties you have to understand. The third property is, look, this is the isoprofit curve of farm 1. Hmm? And the quantity of farm 1 is measured along the horizontal axis. Okay. The property is, closer the isoprofit curve to the axis, higher the level of profit. Closer the isoprofit curve to the axis, higher the level of profit. That means the profit level along this curve is greater than the profit level along this curve is greater than profit level along this curve. Okay. So closer the curve to the axis, higher the level of profit. Why? You can ask me why, ma'am. Look, take any constant, just a minute. Take any constant level of Q2. Hmm. Just take any level of Q2, say like this. Okay, it's constant. Now, along this one, the Q1 is here. Along this isoprofit curve, Q1 is here. Along this, it should be like this. এটা একটু কাছে না হলে এটা মেলানোই গেল না। Anyway, so I'm just trying to compare this and this. The first two, because the third line is beyond the reach right now. So look what happened. The output produced at this level is greater than output produced at this level. Q1 here is greater than Q1 here. So if you are producing more and more Q1 given Q2, that means you are catering more and more markets. So your profit level is increasing because your profit is P into Q. If P is constant and your Q is increasing, if P is constant and Q is increasing, then your profit share is increasing. So that is why if it is close to the axis, that means more and more Q1 is there. So your pi 1 is also higher. Is it okay? This is the third property. The third property is okay.
Yes, ma'am.
Now the fourth property. Okay. What is the fourth property? The fourth property, to explain the fourth property, I need, uh, okay. To explain the fourth property, I should draw another diagram. Just a minute. Look, okay, that will help me. Look at this line. This line, I can say this is the reaction curve of form 1. This blue line is the reaction curve of form 1. Why? Because what is the reaction curve? I think it is here. Yes. This is the reaction curve. No? R1 and R2. I'm just going back to the Purno. That was a reaction curve R1 and R2. I'm saying R1 is this one, that blue line which I was showing you. This is that R1. Why? Because along the R1, just a minute, try to find out the slope of R1. Yes, look. The R1, look at the slope of the reaction curve, dq1, dq2. Okay. And along, yes. You know? Yes. When, look, what is the slope of the isoprofit curve? The slope of the isoprofit curve is uh, dq2 dq1, right? And when it is at the maximum, then dq2 dq1 is equal to 0, right? When it is at the maximum, then dq2 dq1 is equal to 0. It is rising, rising, rising. It approaches 0, and then after it is falling. And along the reaction curve, your dq2 dq1 is equal to also 0. That is how you derive the slope of the reaction curve. Right? So this is why all the points, remember, all the points of your reaction, all the points of your um, isoprofit curve, all the highest points like this, where dq2 dq1 is equal to 0, these are on its own reaction function or its own reaction curve. Okay? So it is actually R1. This is actually R1. This is actually R1. Okay, and you have R2 like this, and R2 is also there, just like before. Okay, so here, this is the thing first. So these are the four properties. So what are the four properties? First of all, it is inverted U shape. The second one is they are parallel to each other. The third one is closer the isoprofit curve to the axis, higher the level of profit. And the fourth one, all the points where dq2 dq1 is equal to 0, that is slope is equal to 0, they are on its own reaction curve. Okay, so as this is the isoprofit curve of form 1, so the reaction curve should be R1. Okay, now I am coming to this is all, look here, there is no Stackelberg model, it's just the isoprofit curve. So now I am coming back to the isoprofit curve. Or rather, I'm coming back to the Stackelberg model. I'm sorry, it's coming back to the Stackelberg model. Now, what happened in the Stackelberg model? One farm is a leader and another farm is a follower, right? So here, farm 1 is a leader. We assume farm 1 is a leader and farm 2 is a follower. Now, when farm 1 is a leader, so what is the objective of the leader? Leader is always trying to maximize his profit. And he will change the quantity, he will change his decision and everything, but he is not interested to influence his profit. He is trying to keep his profit constant, right? This is I'm the leader, then why not? Okay, so I'm trying to intact my profit. I will change Q1, I will influence Q2 and everything. I can do anything with the market so that my profit will be constant. That can be done only by the leader. Follower cannot do that. Because it is ultimately he is dependent on the leader's decision. So if leader will change his decision, then follower has to change. So in that case, the profit of the follower cannot be constant. It will vary because it depends on the leader's decision. But as leader is independent in that sense, so leader knows that I can maximize my profit and I can make constant profit throughout the program. So ISO profit curve is actually the profit curve of the leader. Okay, when you can draw ISO profit curve, then it is representing the leader situation. Okay, Follower cannot have any iso profit curve as there is no constant profit for him. Is it okay? So pi, as I'm saying, so that green lines, the iso profit curves, this is for leader. This is representing the leader. Is it okay?
Yes, ma'am.
Okay. So you have one leader, and the leader is represented by this green line. What about the follower? As I said, for the follower, it is not profit. It is not for the follower. It is not possible to make constant profit. His profit will definitely change, but he must have a reaction function because he is dependent on the decision of the leader. Okay, so his, his there is a responsiveness of the follower with respect to the leader, so that will be represented by his reaction curve. Okay, his profit is not constant. Okay, very okay, but the thing is, he is responsiveness. There is a responsiveness of the follower with respect to the leader's decision. So that responsiveness will be represented by his reaction curve. So there is one R2. There is one isoprofit curve which is replacing the R1 because now farm 1 becomes leader. So R1 is replaced by the isoprofit curve, but R2 is there. Okay, so what will be the diagram? That is the diagram. Okay, before going to the diagram, let me again explain the mathematical portion a little bit. So pi 2, this is the leader situation. So as I said, leader knows that, sorry, this is the follower situation. I'm very sorry. This is the follower situation, and follower knows his decision is not influencing leader's decision. Okay. So CV of the follower is 0. So this is pi2 p into q2 minus c2 function of q2. Look, here I am replacing that constant cost situation. Huh? Here the cost is variable. Now what is the first order condition? D pi to dq2, it will be p plus q2 p prime minus c2 prime is equal to 0. So if you just make this side and that side, it will be m2 is equal to mc2. Just like mr is equal to mc. So that condition prevails. Whatever be the situation, your equilibrium will be like this. Mr is equal to mc. So this is for form 2, that is the follower. And depending, if you differentiate it with respect to q2, how to get the reaction function and all. So that is there. So for the follower, q2 is a function of q1. So this is actually the reaction function of the follower. Okay, this is the reaction function of the follower. So follower is done. Now what about the leader? Leader is here, pi 1. Again, this equation is very much similar to the follower. Okay, but here, look, P is a function of Q1 and Q2. So when the Q2, from this equation, Q2 is a function of Q1. So you can replace this part. Q2 can be replaced by R2 Q1 just by this reaction function. Okay, I'm replacing this. Fine. So Q2 is replaced by its reaction function, that is R2 Q1. And everything, all other things are same. Now the first order condition, del pi 1 del q1, it will be p plus q1 p prime 1 plus r2 prime. R2 prime is what? R2 prime is the slope of the reaction curve of the follower. So this is the slope minus C1 prime. And why you are getting this slope? Because here you are getting dq1 dq2. Okay, and that is non-zero. So this is how you are getting the function of the leader. So leader's optimization is there, followers optimization is there. So we are getting the mathematical part of the optimization. Then what is the diagram? This is the diagram. Look, actually in the single diagram I want to solve two problems, a comparison and the equilibrium. So what is the equilibrium first? Equilibrium, look, this is your R2 and this is the isoprofit curve. This is the isoprofit curve of farm 1, that is the leader, and this is R2, that is the reaction curve of the follower. and they are tangent to this point. If you are having any isoprofit like this, you know the leader is always trying to maximize his profit. So he is not happy with this curve. He is not happy with this curve because if he can shift this curve closer to his axis, then the more profit will be there. So he's always trying to do that, and he's a leader. He can do that. So finally, the equilibrium will be at the tangency, at the tangency of the isoprofit curve and the reaction curve of the follower. Okay, so E2 is the equilibrium point of the Stackelberg model. Remember, E2 is the equilibrium point of the Stackelberg model. Okay, now this is a comparison. Sometimes the questions are coming. No, what is the difference or how, compare Kuno and Stackelberg? So the thing is like this. You have to draw R1 and R2 first. Now, all the maximum points of the isoprofit curve should be along the R1. And you have R2 like this. Now, in the Kuno, you know the equilibrium is at E1. That is just the intersection between the two reaction curves. That is E1. But in Stackelberg, the equilibrium is at E2. Right? So E1 is the Kuno equilibrium, E2 is the Stackelberg equilibrium. Now, if you draw one isoprofit through E1, you can see that the profit of the leader, that is form 1, under the Kuno is quite less than the profit when he is a leader. Okay, so the profit is increased if you can be a leader, and that is why there is a competition to be a leader. Okay, if you are not a leader, if you are just like your follower, then your profit level is represented by this isoprofit curve, and this profit level is definitely lower than the profit along this isoprofit curve, and you can achieve these isoprofit curves once you are a leader. That is why as you can increase your profit level to be a leader, everyone is interested to be a leader. So what will be the conclusion? What is the comparison? That output produced under the leadership is greater than the Kuno. The leader's output is more in the Stackelberg than Kuno first. And the profit level of the leader is higher under Stackelberg than Kuno. Okay, so this is the comparison part. Tell me up to this point if you have any query. If you don't have any problem up to this point, I want to discuss the next one, next model.
And what is the reference for this, except for Ryan and Pierce?
Pindyke. If you have any problem from the Stackelberg, you are free to ask. Otherwise, I will start the next model. That is the Swizzy model. Okay, take a 2 minutes break. Think of it. So any problem?
No, ma'am.
Okay, in that case, I'm going to the next model. Hmm? That is the Swizzy model. Okay, Swizzy, again, you can understand it's the name of an economist, Swizzy. So, what is the Swizzy model? Swizzy model is trying to explain the why price is sticky. That means why the price is not changing. You know, when we are discussing about this model and that model, always we are taking the price as a very flexible one. Huh? If leader wants, he can change the quantity, that will be followed by the follower, and the quantity and the price will change. When Kurno, in case of Kurno, if Q2 will change, then Q1 will change, then again Q2 will change, so Q1 will change, and that process will uh, continue up to the stable position, right? So everything, whatever we are dealing, we are thinking that price and quantities are very much flexible. Depending on the idea, depending on the decision, depending on the requirement of the farms, they can change price easily. But if you come to the reality, you can see the price of the commodities are not changing so frequently. Actually, they are sticky. They are moving maximum. They are moving along a range. It's not like that over the time, overnight it will double. It's very rare. In general, the price is sticky. Okay, so why? So actually, the Swizzy model is called the sticky price model. It is trying to explain why the price is not changing. Hmm. So in that sense, it is a bit realistic in nature. Okay, so it's based on the concept of the kinked demand curve. Here, the demand curve is not like the demand curve we know. It's a downward sloping straight line curve and all. It's a downward sloping. Obviously, there is law of demand. Here also the demand curve is downward sloping. That part is there. But demand curve is not a smooth one. It may be a curve, it may be a straight line, but it's not a smooth one. It's a kinked one. Okay. This is the second property. Why it is, I will explain. And the third one, yes. To explain the second bullet, we need to know the third and the fourth bullets. Here, what happened for the particular farm? It is the oligopoly. First of all, it is the oligopoly structure. Huh? No doubt about it. When the farm will reduce, this is actually the reality. Just listen, you can understand. When that particular farm will reduce the price, when the particular farm is reduce the price of its commodity, then other farms will reduce the price. Because if it is not, then the farm which is reducing the price, he will capture the total market. All the consumers are going to purchase from that particular seller because the price is reduced, right? So just to be in the market, just to stay in the market, other farms has to reduce the price, right? So that means with respect to price, if price is falling, then other farms prices are also falling. So there is a responsiveness, right? So conjectural variation is zero. Sorry, conjectural variation is non-zero if price is falling. Look at the last bullet. Conjectural variation is non-zero if price is falling. Up to this point, is it okay? And how it is non-zero? In which direction? It is positive. If that particular farm is reducing the price of its commodity, other competitive farms, they have to reduce the price of their commodity. So the prices are going to the same direction. One is reducing, the others are also reducing. Okay? So if price is falling, if the price is reduced by a single farm, then conjectural variation of all other existing farms is non-zero. বোঝা গেল? Is it clear?
Yes, ma'am.
Okay, I'm explaining it again. Yes, let me explain it again. I'm writing that conjectural variation because that creates a confusion because of my mistake. So here it is the look, here it is the price. Here the Swizzy model is actually showing the price responsiveness. Here quantity is not so important. So it's a price model. Okay. So here I'm writing del of key del holo. Del P I by del P J.
Ma'am, can
Okay.
we consider it as price war?
Yes, yes, yes. If price is falling, then definitely it's a price war. This is the conjectural variation of which form? Tell me.
J.
Yes, this is the conjectural variation of the jth form. Okay, so del pi del qj, this is the conjectural variation of the jth form. And here the jth form is our concern. So if the jth form is reducing the price, if jth form is reducing the price of its commodity, then all other existing firms have to reduce price of their commodity. Otherwise, they cannot exist in the market. They cannot survive in the market. Okay. So this is not equal to zero. This is not equal to zero because del pi will also change. If pj will change, then py will also change when sorry when that tarika when pj is falling. Okay, when pj is falling, then it is not equal to zero. But if pj is rising, if pj is rising, that means that particular firm is rising the price of its commodity. So actually he is making his own loss. If in the competitive market you are trying to increase price of your commodity, you are going to lose the market. Okay, you are going to lose the share of your market. So in that case, other firms will not increase price of their commodity because it's a price competition. Okay, if you are increasing price of your products, so it's your problem. But I am not going to increase price of my product because I know once you are increasing the price, from tomorrow my market share will rise. Because now relatively I am cheaper. My product is cheaper. So I will get more market share. Then why should I raise the price? So I will not follow you when you are increasing price of your product. So that means when Pj is rising, then del Pi is equal to 0. No one is following. Okay. So in that case, conjectural variation will be 0. So if price is increasing, then conjectural, now look at the third bullet. If price is increasing, then conjectural variation is 0. If price is falling, then conjectural variation is non-zero and it is positive. That means both are going to the same direction. You are reducing the price, I am also reducing price of mine. So we are going to the same direction. So it is positive. Now 3 and 4, these are clear. Don't look at point 2. I will discuss it after some time. 2, 3 and 4, these two, 3 and 4, these two bullets. Clear?
Yes, ma'am.
Okay. Now I am coming to the second bullet. That is the kinked demand curve. Okay. So what about the kinked demand curve? Why kinked demand curve? That is the thing, no? Why King demand curve? Here also I have to draw. Where is my pen? Yes. Okay. Here I am going to draw the King demand curve. What happened? Say this is my initial point. Okay. This is my initial point. This is my starting point. Now, given this point, if I will reduce price of my commodity, then all other firms will reduce price of their commodity, as I was telling you, right? So in that case, my market share will fall because all other firms are also doing the same thing what I'm doing. So in that case, my demand curve, the demand curve which I am facing for the price less than the current price is like this, a little bit steeper. But if I will increase price of my commodity, no firms will follow me. So I will lose a significant part of the market share because actually I'm a fool. That is why I'm increasing the price in this competitive world. Now, so then the market share of my product will fall drastically because all others will take the market share of mine. Huh? So in that case, my demand will be a bit elastic. So it's like this. So if I will increase the price from the current price, as no one will follow me, so I will lose a significant market share. So the change in quantity demanded with respect to change in price will be very high. But if I reduce price of my commodity, as all other farms are also doing the same thing, so the change in quantity demanded with respect to change in price for my commodity is relatively less. So my demand is inelastic. এটা বোঝা যাচ্ছে কি? The
Okay.
product of my commodity is inelastic. হ্যাঁ, এবার বলো।
Can you repeat once more?
Yes. This is the starting point, first of all. This is the starting point. Okay. So from this price, here we are measuring the price, and here we are measuring the quantity, right? We are going to draw the demand curve. So if I will reduce price of my product, as all other firms will follow, so the demand will definitely increase. As price is reduced, the demand will increase. But the del Q by del P for my product, that is the proportionate change in demand with respect to the proportionate change in price for my product will not be so significant. The change in quantity demanded for my product will not be very high because all my competitors are doing the same thing. So the increase in demand because of the fall in price, it will be shared among all the farms because everyone is reducing the price. But if I increase the price, no one will follow me. I'm the only one. I'm the only fool. So I'm increasing the price. So in that case, I will lose a significant market as no one is following me. So whatever fall in demand is there, the total fall is only because of my product. No one is sharing my loss. So the change in quantity due to change in price when the price is increased is quite high as compared to change in quantity due to change in price when price is falling. Is that clear?
Yes, ma'am.
So that is why for the any price higher than the given price, my demand curve is flatter, that is elastic. And for any price lower than the given price, my demand curve is relatively inelastic, that is steeper. So this is why my demand curve is a kinked demand curve. There is a kinked one. Na? The demand curve is like this. So it's a kinked demand curve. And you can ask me, why, ma'am, you are starting from here? There is no explanation for that. I'm sorry. It is not given in the Swizzy model that why we are starting from here. Why not here? Why not here? Why it is from here? So it is said in the Swizzy model that there is a price given in the market. Say it is here. And given that price, if you increase the price, then what will happen? If you reduce the price, then what will happen? That is the concern of the model. But why this price? That is why the existing price is this one. It is not explained in the model. Okay.
Ma'am, what if the product, the commodity has an inelastic demand curve? Because then if price rises, there is
Uh,
no effect. All the firms are increasing their prices.
no, no one will increase the price. You are price competitor. Why can you increase the price? How can you increase the price? You will lose the market share.
Ma'am, but if the product has an inelastic demand curve, then
Still,
the firms will.
still, yes, I can understand that you are telling about the agricultural products where the if price is increasing, your total revenue will rise. You are thinking in that respect, now
Yes,
that
ma'am.
increase in.
I was thinking about a pharma company.
Yes, yeah, the agricultural product. But even in that market, if there is a competition in the market, na, for any type of product, if there is a competition in the market, no one is interested to increase the price. If you are the single seller, then you can think of it. And I think this is the concept from your sem4. So in that case also, we are thinking that if the producer will increase the price, then what will be the total revenue? But as it is the competition, it's a competitive market, so no one is interested to increase the price except there is a collusion. If there is a collaboration, there is a cooperation and all that, then only they can do that. It's just like a monopoly. If you have some monopoly power over the market, then only you are interested to increase the price. If you are in a competitive situation, you are not interested to increase the price. That firm is doing the thing, I don't know why, but if he will do, I'm not telling you he is doing this thing, but if he can do that, then the demand will be elastic for him.
Ma'am, but if we do a case study on Apple, so products of Apple are more than, like, there is a hype in prices. Still,
Yes,
there is.
Apple, no, look, the Apple is pretty, Apple means agricultural product.
No, ma'am. I was talking about the like Apple company, Apple iPhone.
Yes, this is a monopoly. Apple is
How's-
produced only by that Steve Jobs, no one else.
Ma'am, but it is a competitor of mobile phones, na? There is huge competition in.
So you are talking about the mobile phone company.
Yes, ma'am.
Okay, so what about the, now tell me.
Ma'am, there is a huge price gap between Android phones and iPhones, right?
Mhm.
So why, like, there is still high demand for Apple phones as compared to, if we compare Apple and Samsung, there is still similar kind of demand for both Apple and Samsung phones.
No, no, I don't think so. Samsung's demand is quite high as compared to Apple. You belongs to in such a uh, in such a section of the society that you are thinking the demand for Apple is also very high, but in reality it's not like that. How many of the general people have Apple in their hands? Tell me. But people have Samsung, people have MI and all this, so they have all. But demand for
If we
Apple
consider,
is very much concentrated for a particular part of the society.
ma'am, but if we consider the US economy, there is actually high demand for Apple.
Yes, because it is produced there. First of all, the price is lower compared to the India, and the thing is, their per capita income is quite high. Whose income is high, they are only very much eager to have Apple. No one else. General people are very much happy with their MI and Samsung, and the features are quite different. The products are actually it's a mobile. That's true, but other features are very good in case of Apple. There are so many features which are not available in any other phones. So they are giving some specialty, so they can charge higher price. But for the same product, for the same product, you cannot do that.
Okay, ma'am, got it.
But I don't agree with you that the demand for Apple is higher than demand for Samsung. I don't think so.
No, ma'am, not higher. They have demand at similar levels.
Similar.
Yes, ma'am,
That
similar.
means same demand.
Yes, ma'am, almost same demand. They have almost same demand in the market.
Is there any proof? Do you have any data or anything? How
Ma'am,
can you
on
say
US,
that?
I was actually telling about US economy. Then you said that you were right that it is a the Apple phones are produced majorly in US, so there
Hmm.
will be a low cost, and moreover there are people spending more. There are It is a developed nation, so the
Yes, their per capita income is quite high. What they are using now,
so
they are
yes, ma'am,
the
that can be
you
a
know
reason.
the household helpers. They also have the car. They are driving their own car and coming to do the job. But in our area, it's not possible. We cannot imagine the situation that our household helpers are coming with their own car. No, so
Yes,
it's
ma'am.
quite different. You cannot compare in this way.
Yes, ma'am, I got it.
So anyway, so we have the king demand curve. Now, once you have the king demand curve, now I'm coming to my equilibrium. Look, this is my demand curve. Any other question? Okay, so this is the king demand curve, that blue one, DD as I derived. And if you have the king demand curve, your marginal revenue curve will be a discontinuous one. Up to this point, look, up to this point, when your demand curve is a flatter, your MR will be relatively flatter. When it is steeper, then your MR will be steeper and there will be a gap. Okay, there will be a jump. So your MR is like this. Look at my cursor. Your MR will be like this, flat, 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 flat. At this point, it is discontinuous, and then after it's a relatively steeper MR. Okay, so if the MC, that is the marginal cost, there is no such constraint on the marginal cost. If the marginal cost curve is going through this discontinuous part of the MR, then you will get the sticky price. Look, if your MR is going through, let me use my pen. Just a minute. Right now, your MR is here. If your MC, sorry, right now your MC is going through the discontinuous part of your MR. If your MC is at a bit less, like this, then also you will have P star as the equilibrium, right? If your MC is a bit higher, like this, then also you will have P star as your equilibrium. And that is how, if your cost is changing, but the price is constant. Why? Because your MC is going through this discontinuous part of your MR. This is a range. Okay, this is a range of the MR. If your MC is within this range, then whatever change in your cost, price will be same. So this is how the Swizzy model is explaining why price is constant, why price is sticky. Sticky price model. Okay, why price is sticky. Okay. So this is Swizzy model. We have two other models. The first one is a Bartrand model and the second one is a price leadership model. We will explain it in the next class. So before leaving the class, if you have anything to ask for today, you can ask. Is there anything you want to ask?
Ma'am, can I ask something from Monopoly?
Oh, yes.
Ma'am, in variant it is given that for a constant elasticity demand curve, the markup will be a constant, like it will be a constant, markup will be a constant one. But ma'am, when elasticity, it is given that constant elasticity demand curve means I have to take E is equal to 1
Yes.
because for the rectangular hyperbola.
Mm.
Then ma'am, how can there be a markup? That in that case there will be P is equal to MC. Like that will
What
be
is the
0.
formula of the markup pricing?
P minus MC by P equal to 1 by. That means the learner index.
Hmm. And this is equal to 1 by E.
Yes.
So your elasticity is constant, it's 1. So 1 by 1 is equal to also 1. So that is why the markup is constant.
But in Ma'am Snyder, it was also given that if suppose elasticity is 2, then
Okay.
that also that will be a
That
constant
is what
markup.
you need elasticity. Yes. Yes, why not? Because again it's 1 by 2. It's a constant.
So ma'am, elasticity can be constant only when it is rectangular hyperbola, isn't it? Because elasticity varies along the demand curve.
No, no,
But
no, no, no. Yes, that is true. That is true. But if your elasticity is -2, that is also possible. Why not? Why not constant elasticity? And I'm not getting your point actually. Why elasticity one is only the constant? Why not two and three?
ma'am, because in linear demand curve, elasticity varies. Like when we go up the demand
Uh,
curve, then
uh,
that will be greater than 1. So it
uh,
varies. But
yes.
since it is given in the book, in the text, it is given that constant elasticity demand curve. In that case, it should be rectangular hyperbola, no? Like for a rectangular hyperbola, only E is equal to 1. There,
No, 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 no,
elasticity
no.
varies.
You are talking about the total demand curve, but for a particular point of your demand curve, you may have elasticity is equal to two.
Yes, yes, point I can
So
have.
yeah, so that's why you are getting the constant markup. That's the problem.
Okay.
Okay, students are very much depressed and all. I think because